since we're going to be taking a look at a lot of COVID-19 data, I figured I'd first start by talking about exponential growth. Okay, so let's take a look here. Oh, that's not what I wanted. All right. So I will first start by posing this problem to you. You have a pond, and the pond has lily pads on it. So if you're not familiar with lily pads on it, they're the little plant that we see right here. Okay, and on the first day, I want you to imagine this pond, the water is completely empty. The surface is just water, except for one single lily pad. And we know that lily pads grow very quickly. As a matter of fact, each day, the number of lily pads doubles. And we also noticed that, wow, we waited for 20 days from the day we first noticed the first lily pad, and the pond was full at the end of those 20 days. Okay, so then, considering this situation, I might ask you guys, when would you have expected the pond to be half full? So again, starting with 1, every day the number of lily pads doubles, and after 20 days, we notice that the pond is full. Okay, so pause the video, think for yourself, put out your guess there on when you think the pond was half full. Okay, if you said 10 days, you are incorrect. That is not right. And it seems intuitive enough that if it's full after 20 days, surely then after 10 days, the pond would have been half full. But that is not how this situation works. It's actually 19 days. And you may not believe me, or it may not make sense to you right now, but let's take a look at the numbers. If you consider each, this is a table of the number of days and the number of lily pads. Okay, so this is the 20th day. Where if it doubles every single day, we would have 524,288 lily pads. But also, you should think that if from one day to the next, the number of lily pads doubles, that would mean that if we were to go backwards, that means the previous day would have exactly half as many lily pads as we notice at the end of the next day. And so if we know that the pond is full right here on day 20, you'll notice that the next time where we have 1/2 of the lily pads in the pool is the day right before. And actually on day 10, you don't even have 1/1000th of the lily pads that you had in the pool on day 20. It's considerably less because the lily pads are doubling in the pool every day, not just adding a couple amounts each day. This is the idea behind exponential growth, and it's a concept that I would say as people is very difficult to wrap our heads around. In other words, the growth happens much faster than we would normally expect, and that can be very challenging when we're trying to logically assume or estimate what's going on in exponential growth situations. The growth is very, very rapid. If I were to look at the presentation of this original problem, it's actually this word right here, where we say the number of lily pads doubles every day. That makes this problem exponential growth. It's saying that every day, instead of adding a certain amount of lily pads, we are multiplying by the same number. That number in this case being 2. Okay, so now what I would like to do is I would like to model exponential growth in Google Sheets or Excel. And these are the 2 ways how we will do it. But what I would like you guys to do is I would like you to open up a brand new spreadsheet. This one right here is the one in the links right below down in the description. So if you download that link, you will need to make a copy of it because you will not have access to the original file to editing it. And when we make this copy, you'll see that we have a spreadsheet here with lily pads, and there's a spot right here that says growth factor. The growth factor is the number that you are multiplying the number of lily pads by each day. In this case, I want you guys to think about what that growth factor is. And we'll put that right here. Okay, what we're going to do here is we're going to make Google Sheets into our kind of graphing calculator. We're going to graph First of all, we're going to fill this table with the days and the number of lily pads on that day, and then we're going to graph that data, and I want you guys to see that it obeys an exponential growth curve. Okay, so we will do it this way. This is day 1. I want this to be 2, 3, 4, 5. Now, of course, I could type it in manually, but there is an easier way of doing that. I want this day to be the previous day plus 1. And if you guys remember the last time, we can do that with a formula. We'll type the equal sign and do it this way. Excuse me if you can't see my keystrokes. That should be a little better. Okay, so what I did was I said this is going to equal the previous cell plus 1. Okay, now I've done that. Now I can either copy paste or you can click drag all the way down. That didn't work quite the way I wanted it to. Okay, much better. All right, and it looks like I had to go down actually one more line from before. Oops. I will fix that in the original file for you guys. All right, so now we are here. We have our table. It looks nice and clean. Hopefully nicer than this one looks. Okay, so we have this up to day 20. And now what we are going to do with this lily pad, we said each day the number of lily pads we have is double the previous day. Now we could do it like this. I could do equals 2 times the previous day and click right here. But what I'm going to do is I'm going to say I'm going to multiply this growth factor by the number of lily pads. And it may not be clear to you why I use this cell for that, but it will be clear in just a moment. So again, we're going to multiply the growth factor, this orange box right here, by the purple box right here. We're going to basically double this previous number. Okay, so now if we're going to copy paste, actually we want to stay in this box, the orange box right here. So we need to lock some stuff in. We're going to lock in the 2 in G2 with a $sign like that. And when we do that, now we should be able to copy paste all the way down like this, and it should give us our 524,288 at the bottom. Very good. Okay. Now that is basically doing this approach right here, where we were multiplying the previous day by the growth factor. Another way of doing this is graphing this as an exponential function, where a times k to the t minus 1, where a is the starting value. Okay, so how would we do that? We're going to do this equals, and now we're going to type the starting value of lily pads. That was 1. And we're going to multiply this by the k, which is the growth factor. Again, we're going to click right here. And we're going to raise it to the t minus 1 power. If you want to know how to raise it, it's actually this little caret symbol that is available on your keyboard by hitting Shift 6. Alrighty. And the time, actually, that we type is not going to be t, it's going to be the day number, right? So I have to click right there for the day number. So now that we have our formula here, we have this equals this, and now we can just copy this all the way down. I forgot to lock in the growth factor like that. Okay, so now we have 1 times G2 with a $sign locking in the 2 there for the growth factor, raised to the B3 minus 1 for my formula right here. This is basically right here, the time minus 1. Okay, so now I'm going to copy paste this all the way down, and I should have the exact same numbers that I had over here. Again, showing that these are 2 different ways of modeling the same thing in Microsoft Excel or Google Sheets, I guess is what we're working with right here. Okay, so now we've got our data. This is a beautiful looking exponential growth. The next thing I would ask you to do is to graph it. And so you can do this by going to Insert and inserting a chart over here. And it looks like this. You should have a little bit more real estate than I will on my screen, so I'm going to resize this so you can see what's going on. And I'm going to double click here so you can see the setup thing that goes on here. Okay, so the first thing we need to do is we need to drop in our data here. So it says x-axis. Well, this is we're graphing the number of lily pads versus the time or the day number. So for the x-axis, we're just going to click here. So basically I clicked right here where it says x-axis. And it says select the data range. And so when it says select the data range, you can actually just click drag all the way down the data like that. And you'll see that it fills in some garbage right here. But you don't have to worry about that because we're just going from here to here. Okay, there is our x-axis. Let's actually do it with the y-axis first. Okay, we'll do the y-axis like this. I'm going to do shift control down like that, and that will do that. And now our x-axis has come in as the day on our scatter plot. Okay, so this is not the way we want to graph it. We want it to look like a series of dots, and that is the option right here. Under chart type, we'll go to scatter plot right here, where it says scatter chart. And when we click that, there is a nice looking exponential growth, and you can see that that shape actually looks very similar to this one right here. So now we've got a nice little exponential growth looking thingy, and I want to show you guys what this factor of 2 means. When we put this growth factor of 2, I just said, why don't you put it right here? The benefit of doing this is all of these formulas that we have right here, whether you use the left column or whether you use the right column, all of these formulas rely on this cell right here. And so now I could present to you the problem, well, what happens if the number of lily pads in the pool tripled every day? Or what happens if it quadrupled every day? Now, if you had typed in the number 2 into these formulas, you would now need to change every single one of these cells to change it to the number 3. And then if I said, oh, I didn't mean 3, I meant a different number, you would then have to change it again and again and again. But since we have the growth factor here, now if I were to say, what if the number of lily pads tripled every day? Well, you can just type a 3 here, and it will triple all of the previous numbers. And you can see the axes on my graph adjust accordingly. We have a much bigger result because we're tripling every single day. Or you could say, what happens if it grows by 1.5 every day? Well, obviously we have some fractions, but you can see this doesn't grow quite as fast, and we have a slower exponential rise. So what I want to show you guys here is one, how to understand exponential growth, but also how in Excel we often put things that we want to be changing a lot or tweaking inside or off to the side of our data. And that allows us to modify those numbers in order to make sure that we can change it repeatedly or depending on what we want the value to be. And so we'll be doing this quite a lot in the next exercise, but I wanted, that's all I got for you guys right now. Let me know if you guys have any questions or if there's anything I can do to make this clear.